Okay, everyone, we're back for the final lesson of this unit, and this time it's called Parallel Lines and Transversals. And what I want to say to you is if you clearly learned the last lesson, and that's where we looked at the interior alternate angles and the exterior and the corresponding and so on and so forth, if you truly understand those definitions, this lesson will be a piece of cake for you. The one difference I suppose I should say to you now is if you look at this diagram right here, you can see that we have our two lines, line 1, line 2, and we have our transversal, and that's just a line that crosses two other ones. The only thing that maybe is of note here is these two lines are perfectly parallel to each other. That means they run perfectly straight alongside each other. They will never move closer, and they'll never move farther away. Now, what happens when those two lines are parallel to each other and you run a transversal right through them, you get some very special angle relationships. And that is summed up down here. So what's going to happen basically is if you have, in the very last lesson, we learned about these, the interior alternates, exterior alternates, and so on. Well, now we're going to use that information to find missing angles. So all of these things now hold true. Okay, so now if we have interior alternate angles, they must be equal. If we have exterior alternate angles, they must be equal, and so on and so on and so on. Now, the one thing I should point out here is there's kind of a twofold process here. You will often be given, you'll often be asked to solve for an angle, and let's just say it's 30 degrees. That often won't be enough. What you'll need to do is you'll need to state, well, why is your missing angle 30 degrees? And what you'll have to do is realize which of these principles or facts did you use to find that missing angle. Let me give you an example, okay? So this is really, it's a little bit of problem solving, but like I said, if you can apply what we learned last lesson, well, then that should work out for you really, really well. So let's just kind of go towards the bottom of the page. I'll zoom in here just a little bit, not too much. Okay, so what we have here is, of course, we have our transversal, which is T. We have our two lines. And as you can see that they are parallel lines, okay? So that means we kind of have all of our different angles in place. And those special angle properties are also going to be in place. So let's see what we can figure out here, everybody, okay? So let's see, we have been given, the only angle we've been given is angle 4. We've been given, angle 4 is 122 degrees. Now there's not necessarily, I want to point this out right now. You do not need to follow a certain order. Like if you look at the solution here, I mean, it's given away, angle 1 is 122, but the point I'm trying to make is, if you can apply one of the rules and solve for number 2 first, by all means. If you can, you do not have to follow the right order. But let me just show you an example here. So if they tell you that angle 4 is 122 degrees, well, why can I figure out number 1? Well, number 1 is a corresponding angle to number 4. Remember, a corresponding angle is when you have your two intersections. There's an intersection and there's an intersection. And remember, if you look at that, angle 4 and angle 1, they occupy the top spot in both of those intersections. Therefore, what you know is, if angle 4 is 122, angle 1 is 122 degrees. But remember, like I said to you, if you don't just go angle 1 is equal to 122 degrees. If you get that, that's great. But most of them will say, well, how did you know this? You will have to say because they are corresponding angles. Okay? Moving along, remember, we can bring up anything in this unit here now. So let's figure out, they look at number 2. Number 2. Now, number 2 is right next to number 4. Well, how the heck can we figure that out? Well, you see, what we have here, everyone, is we have two angles right next. Oh, sorry, oh, that's terrible for a half circle. I apologize. If you look at angle 2, it is right next to angle 4. Okay, and what we have is we have two. You might remember the word adjacent angles, because remember, this is a ray, this is a ray, and this is a ray, and they have the same vertex. Now, I like drawing that shape. When you have two angles that are adjacent and you have a straight line, something like this, There's your straight line. You always can draw a half circle. How many degrees is that? Well, that's 180 degrees. So if you apply that now to this question right here, we have adjacent angles. 2 and 4 are right next to each other, and we have this flat line. So that's 180 degrees. So to figure out number 2, or angle 2, you simply would go 180 degrees, take away 122 degrees, and that would give you 58 degrees. The ruling is they are supplementary angles. Then, applying here some more, we have to figure out number 3. So how do you figure out number 3? Well, I'm just going to put right here, we know that angle 2 is 58 degrees. We were also taught something in the last lesson about vertically opposite angles. You see, at this intersection point, angle 2 and angle 3 are opposite of each other, up and down, left and right. They are opposite of each other. Therefore, we know that they are perfectly the same. So that means if angle 2 is 58 degrees, that means, because they are vertically opposite, that angle 3 is also 58 degrees. So you see, everyone, it's not like we're doing overly complex math, we're adding, subtracting, but I think it's key to point out that everything we've learned in this unit is coming back. So let me be very clear. If you look at your sheet you're on right now, just up a little bit there in the bullets, I'll even scroll to it. You have interior alternate angles, exterior alternate, corresponding angles, interior angles on the same side of the transversal, exterior angles. Well, maybe if we're going to do a good job here, maybe what we should add to this is, remember, there were supplementary angles. What was the other one? We had complementary angles. And why am I adding that there? Well, I'm adding that there because those rules too can also be used to help you find some missing angle values. So now again, I don't want you to be overwhelmed by this. There's nothing overly difficult. But what I'm saying is, if you truly understand the principles of these different types of angles, it'll make finding these missing values a breeze. And now you're going to use these. You're going to use your knowledge now to go on and try some further examples, like this one right here. Now, if you look at this assignment, which I am going to have you do, you see it doesn't just want. It does want you to find angle 1, angle 2, angle 3, and angle 4, but it also wants you to say, well, why? Are they corresponding? Are they supplementary? What did you use? Why is that the case? Okay, so this is something that takes a little bit of getting used to. You have all the knowledge you need, it's just now applying it. So please check your answers frequently and also check in with your teacher. Best of luck.